Hi guys, so we are starting a new unit called transformations, and the first transformation that we're going to talk about are reflections. In order to understand reflections, we need to talk a little bit about symmetry. Hopefully this is not the first time that you've heard the word symmetry, but if it is, okay, basically something is symmetrical if you're able to fold it along a line and each side matches. So if you look at this picture, this butterfly is symmetrical because if I fold the butterfly over this line, it will match up. So basically there's two types of main symmetry. There's vertical line symmetry and horizontal line symmetry. Okay, both line symmetry. But if you're looking at these letters here, okay, you see A has vertical line symmetry. This is a vertical line up and down. The letter B has horizontal line symmetry. And the letter X has both vertical and horizontal. If we take a look at these words, okay, the word mom has vertical line symmetry. And the word heed has horizontal line symmetry, which means that if I fold it over these lines of symmetry, they will match up. Shapes can also have symmetry as well. So if you look here, okay, just a square has not only vertical and horizontal, but it has two diagonal lines of symmetry. This one here and this one here, meaning that any way I fold this, it's going to end up on itself, vertically, horizontally, or diagonal. An equilateral triangle has lines of symmetry. Okay, equilateral meaning all of the sides are the same. A rectangle also has lines of symmetry, but only vertical and horizontal. So take a minute and pause this and decide if the followings have lines of symmetry or not. So if you look through these shapes, the pentagon, number one, actually has 5 lines of symmetry, okay, going through each vertex. So there's 5 there. The Z, although some people will think it might have symmetry, it actually does not. If I try to cut it down here and I fold each piece over, okay, even if we just look here, if I reflect this or fold it over here, it's going to end up here. So this has no lines of symmetry. The same thing with the parallelogram, which is always a hard one for people to understand. Okay, if you take a piece of paper and make a parallelogram, cut it out, you'll see that if you try to fold it this way, okay, or this way, or even diagonal, it's not going to match up. It's going to be close, but it's not going to match up. The Batman symbol, okay, has vertical line of symmetry, but not horizontal. Another type of symmetry is point symmetry, and point symmetry is, I want to say, fairly easy because a quick test to determine if something has point symmetry is to turn it upside down. So if you turn it upside down and you see the same thing, it looks exactly the same, then we say it has point symmetry. So if you take a look at any of these 3 pictures and you turn them upside down, they're going to have point symmetry. They're going to be the same, which means they have point symmetry. And last but not least, rotational symmetry. I'm not going to go into too much detail with rotational symmetry because we talk a little bit about this later on in the unit, okay? But there's different variations of rotational symmetry depending on when you rotate a figure, if you see the same thing, okay, how many degrees or orders of rotational symmetry it has. So we're kind of going to save that for a little bit later. So you're going to also watch the intro video to reflections as well as this one, since this was a short one. So go on to that one.